Today, I'm going to show you how to turn this into this. This is part 3 of my Conway's Game of Life series. If you haven't seen the previous two, check the link to the playlist in the description. So I will start by pausing the simulation. I will remove the set interval and I will just render the state once. So render state so that we can start assigning the colors. So this is the starter shape or the starter pattern. So let's say I want to add some colors to the different parts of this pattern. First question is how I could do that. So after thinking a while, I came up with a solution which could be something like this. Let's say I want to assign red to these three things, then green to this one and blue to this one, RGB. I will keep it simple. So first thing I could do, and again, I went through the thinking before, now I will show you how I solved this, but there are obviously many ways, as every time. My solution is the following. First thing is create some arrays, RGB, with representations of each color. And for convenience, what I'm going to do is represent the colors with just numbers from 0 to 255. So red will be 255, 0, 0. Green will be 0, 255, 0. And blue, 0, 0, 255. Okay, so here I get this strange formatting if I save with formatting. So I will save without formatting, which is done with Command K and then S. So I want to assign red to these two squares. One is this one, another one is this one. There we go, that's the first one. And this is one benefit of JavaScript. Let's say benefit. Sometimes it can help, sometimes it can go against you. But in this case, given that the arrays can hold whatever we like, we are holding numbers or these sub-arrays as well. So we have red in one square, red in another square, and I'll go on assigning these. I will assign red to all this stuff here. So red, 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 and so on. And then green and blue. So we have our colors assigned. Now, this will obviously not work. There's no chance this can work at all. If I open the DevTools and reload, doesn't work, doesn't render absolutely anything. I honestly was expecting an error. Maybe it's not failing because we have to check the conditions, but anyway, it's not working. That's the first thing that we want to fix, make that rendering work. Okay, so this doesn't work. Let's see what we have to change in render to make it work. So if we go to render, okay, if state add row and column when we iterate over the rows and the columns, and if you're not familiar with this code, definitely go back to the first part in the series and start from that. And once you watch those, you can come back and keep on going from here. So we're checking if the state is 1, but now the state is either 0, which means off, or an array that represents a particular RGB color. So this doesn't make sense anymore. What we are going to do is, instead of checking if this is 1, I'm going to check if this is different than 0. So if it's on at all, if it's something different to 0, for now I will assign this class to at least see whether or not we are detecting that the cell is on. If I reload, all right, this is fine. And by the way, I will commit the previous changes. So assigns RGB colors to the Gosper pattern. Then we will have to assign colors to all the other patterns, or the other patterns won't work because there will be a 1 instead of a color, and the rendering code and the evolving code will expect arrays for cells that are on instead of just a 1. But let's keep on going with this. So now we don't want to just add the class on, because that will paint it in this yellow color. What we want to do is assign the actual color we chose for that cell, or the actual color that the current cell has assigned. So let me first remove this class this style doesn't make sense anymore, because we don't want to assign a single particular color. So that's it. And instead of adding a class, what I will do is add a style, which will be the following. I will assign it the background color to the RGB value, and I have to add the RGB elements here. So I'm using string interpolation here. I will do, let's say, const red, green, blue equals state.rc. So I'm using array destructuring red, then green, then blue. If I save this and reload, there we go. Now we are rendering the colors that we chose, which is a great progress. So let me commit this. Shows colors instead of just on and off. So now we have a render method that is aware of the colors. The next thing we need to do is make evolve aware of the color. So let's go to evolve, and before doing that, let me just evolve this one time and render the result, just that. And this should surface any issues or any code that needs to be updated. So let's reload, and again, not working. So let's open evolve and see what changes we need to do. So here we're just iterating all over the state, so there are no changes here. What we definitely need to change is the way in which we calculate the new cell value. So let's look at that code. What do we have here? Here, again, we are checking if we're counting the live neighbors here, and actually now that I see this, I think we can extract this to a separate function. So let's start by doing that so that we can clean up the code a little bit. That's a very important thing to do whenever you are reading code. I think that's one of the best moments to improve the code a little bit. So here, let's create a function. We can do count live neighbors. So what we want to do is extract all this code and place it here. So what do we need? We will need the state. We will need the current row, the current column, and I think that's it. And then we need a result variable, not constant, and we are going to return result. And instead of calling this live neighbors, we're going to call it result. Okay, so then we need number of rows and number of columns, but we can calculate that from the state. I'm not worried about doing this calculation again. I think it's cleaner to pass as few parameters as possible. If we had a later on a performance issue, we could check where the performance issue lies and optimize that part, but for now I prefer to prioritize the readability of the code. So let's remove this. Now we can make this a constant, and we can call the function with the state, the row, and the column. All right, and it turns out that these two are not needed. That's why they are grayed out, so we can remove this. And then this has to be different than 0. And then if live neighbors is less than 2, we return 0. If it's equal to 2 or 3, we return 1. It doesn't make sense to return 1 anymore. So let's return just white for the time being. And this is 0. If it's 3, this is actually no, I was screwing up here. We don't want to return white here. This condition is the one in which we have to keep things as they were. So we are going to return state, row, column. And here, if line neighbors is exactly 3 and the cell was indeed off because we're in the else condition, a new cell is born. And the color that we want to choose for this experiment is a mix of the colors of the 3 cells that gave birth to the new one. So for the time being, just to check that everything is working, I will make the new color white. And what else? I guess that's pretty much it. No, we still have an equals to 1, so I will make this different than 0, and now I think we're there. Let's reload. All right, this looks good. It seems that all the cells that were born now are white, and that looks really good. Actually, I think that we could resume the simulation and everything ends up turning white, obviously, because we are not mixing any colors, but it's good. It's a very good progress. All right, so we have the simulation, but the new colors are always white. So instead of just assigning white to the new color, what I will do is calculate the new color as a mix of the previous ones. But I just noticed that I haven't committed this, so I will commit it as makes evolve color aware, but just evolves with white. Now what I want to do is, instead of returning this white color hard-coded, what I will do is calculate the color as a mix of the other three. And for that, I will need to have the colors of the live neighbors. So that's making me think that instead of counting the live neighbors, what I can do is return the live neighbors themselves, and then I can just check how many live neighbors we have. So here, instead of count live neighbors, let's do get live neighbors, and result will be an array, and instead of incrementing the value, what actually this can be a constant because we're going to be pushing things to the array. So here we can do result.push state at neighboring row, neighboring column. That will be one color, and then we return the result. And here we can do live neighbors count equals live neighbors dot length, and everything should keep on working. Let me rename this to count. Hope the code stays reasonably compact. Maybe what I don't like is this, having the return on a separate line and not having braces. So I will do that, add some spacing here so the code is cleaner, and there we go. Everything should keep on working as it was. Yes, perfect. So let me commit that, gets live neighbors instead of just counting them. And now here I have the exact line neighbor, so we can do average color of live neighbors. So here we can do function average color of colors, and then we know it's gonna be 3 colors, but maybe I want to make that a little bit more explicit. So color 1, color 2, color 3. And here, live neighbors at 0, live neighbors at 1, live neighbors at 2. I just prefer the code to be a little bit more explicit because I find it more readable. And then this should be pretty simple. Result will be an array. I'm gonna start it off as 0, 0, 0. So maybe, yeah, maybe this will get too wordy. Let's go back to the previous way and let's do colors. We can do for let, or we can sum all the colors with a reduce. I guess we can. So const sum equals colors dot reduce, and here we need a callback function that receives the previous value, previous, and the current value, current, and then we have to return the sum. So we are gonna do previous at 0 plus current at 0, previous at 1 plus current at 1, and then previous at 2 plus current at 2, and then the starting value 0, 0, 0. Is that correct? Looks like yes. Return sum sub 0, sum sub 1, sum 2, and all of them divided by colors dot length, divided by colors dot length, and divided by colors dot length. Let's see if this works. Reload, and there we go. Now, as you can see, when new cells are generated, they get a mix of its parents' colors. So if I slow down this animation or this simulation, you will be able to see, let's zoom in a little bit, you will be able to see how the gliders get formed bit by bit. Let's reload, no, let's make it 200. You can pretty much see how they get formed, which is really nice. All right, so there's one more thing that I'd like to fix, which is the fact that if you can see here, the gliders are quite pale. That's because we're making an average of the colors, and that mixes all the colors and makes all of them have less intensity. So what I will do to fix that is come here to average color, and first of all I will remove this because it's not used. Let me reload. It's fine. And another small thing that I will change here is replace this with an array map. Some map s divided by colors length. This should make exactly the same as we were doing before. That's fine. Same thing, but a little bit cleaner. And now instead of taking the average here, I mean, I will keep on summing the colors that obviously could give me a value that is out of bounds, like larger than 255, because let's say I mix red and red, that will give me more than 255, assuming that I have like totally saturated red, which is 255.00. So one thing that can be done here, one way to solve it, is instead of dividing by the length, is first of all calculating the maximum value of the three components of the color. We can do that by math max. So this should be some 0, some 1, and so on, but a better way to do it is just doing sum with this structure sum here, and we will get the max. And here, instead of dividing by the length of the colors, I'm going to divide by max. This will give me an array that will be between 0 and 1, but I don't want it to be between 0 and 1. I want it to be between 0 and 255. So I will multiply by 255, and this should convert the sum to an array that has values between 0 and 255, and that will make my colors much more intense. Actually, as intense as they can be. So let's reload, and now this looks much better. The colors look totally saturated, and it's much easier to see what's going on. So that's great. And let's change this. This is not an average anymore. It's a color mix. It's more general. So let's just commit these last changes. Make sure the colors keep saturated. All right. There is one last thing I want to show you. I was playing with this pattern, and something really interesting is that at first sight it seems like the red and green colors don't mix up apart from this small moment in the middle of the pattern. But if you let it run for long enough, you will start noticing that the red becomes more orange and the green becomes also more orange. So what I did was accelerate the time and see what happens, and actually it will eventually mix both colors and they will turn yellow, which is really nice. I think this wraps up for today. There are a couple of other things that we could do, some improvements that I can think around the code, but let's leave it here for today. Feel free to follow along with the first, second, and this third part and play with different patterns. Feel free to share the code in the comments. You can pretty much play with whatever pattern you like and see how the colors mix around. So as always, if you like this content, please subscribe, leave a like, and see you next time.